Okay. So we're gonna do rates of change high there. Rates of change. So for rates of change, let's start here. So the gradient of a function can be seen as the rate of change, or the rate at which the function changes. In order to find the rate of change of a function at a specific moment in time, we calculate the derivative at that point. Now the rate of change of a function ft at t equal to a is given by f prime of a. So basically, to summarize all of that is, so previously we looked at f of x, f prime of x, we defined this as the gradient. Now the same thing, I'm gonna define it now as the rate of change. So you're just gonna see this weights now. They'll say find the rate of change. And we do it the same way. Same way we found the gradient at a point, we're just gonna find the rate of change at a point. That's what this formula is saying. That is the point, and then just put that point into the first derivative, you get the rate of change. Now, as like before, where we're looking at the gradient, when the gradient is positive, we know the line is going up, so it also corresponds here, it's increasing. When the gradient is negative, the line is going down. Also here it means the rate of change is decreasing, or the value of the function at that point is decreasing. Now let's look at an example. Again, it's page 125 on your textbook. Sorry about that. So on this one, they gave you the formula there. So this formula says is the volume of water in a tank. So that means if they ask you what is the rate of change, you're just going to find the first derivative of this formula, and then they'll give you at which time. So this gives you the volume at a certain time. So T is time in hours. So from the moment the inlet and outlet of the tank was connected to a pump, the volume is measured in liters. So you don't need to worry about a lot of things. You still have to find the first derivative at some point and do the usual thing. That is, substitute the T and get the rate. First question. Now this one also, they like using this with initially. So with initially, you need to understand if you have an equation here with T being time. Initially means time is 0 when we haven't started the time. So you just need to go to the formula, put T0, and then you get that initially we had 6 liters based on the formula. B. So for B, at what rate does the rate, so if you see this rate change. So rate, that means first derivative. Number 1. After exactly 6 hours, that means they want V prime of T, then they also gave you that T is 6. That means you find the first derivative, then you equate, you put T, where you see T, you put 6, and then you get the answer. So let's look at it. Again, V prime of T, again, first derivative, the way we did it. Exactly the way you did it. Now they gave us the time. That means after finding the first derivative, where we see T, we put 6 for the first one, and we're going to put 15 for the second one. So 6 for the first one, you have 12 liters per hour. Remember, the volume is in liters, the time is in hours. That's why liters per hour. Now, again, the question is saying, it's about the rate of change, and I highlighted the words there. C, after how many hours will there be 50 liters? So they gave you the V, this is volume in liters. And then they want the time. That means you just use the original equation. You don't change anything on this one. So 50 liters. Oh, no, it's down there. So yes, 50 liters. So we're here. So 50 is the volume. So you just put 50 there and you solve for T. So just like that. You can use quadratic formula here. So here you can use T is equal to minus B plus minus square root of B squared minus 4AC all over 2A. And then you're going to get the 2. then you're gonna get to 2 answers. So the volume reaches 50 liters after 2 hours, and again after 22 hours. Why 2 hours and 22 hours? So it's like water gets in the tank and it gets full, and then after that the water gets out, and then so it'll reach 50 liters when it's pumping in, and then another 50 liters when it's pumping out. D, after how many hours will the volume of the water decrease at the rate of 12? So they gave you the rate. So they say the rate is 12 liters per hour. So they gave you the first derivative. They want you to find the time when the first derivative equals to that. So as you can see, they gave you that, and then decrease. In this case, be careful. When you say decrease, that means the rate is negative. Exactly, the rate change is negative since the volume is decreasing. So you just have to put negative 12 and then solve for t, and then you're going to get 18 hours. I'll stop there.